Hey, everybody, Mr. Murat. What we're going to do is talk about our balanced equation and what information it tells us. Okay, so a balanced equation is very similar to a recipe that you might make if you're going to make a cake, cookies, anything like that, even chili, something like that. Now, the difference being that in a chemist recipe, there's no units written; they're implied. The units in the equation are moles. So when a chemist reads this, they're going to say that you need 2 moles of H2S and 3 moles of O2, and you will make 2 moles H2O and 2 moles of SO2. So just like any recipe, what you may need to do is that sometimes you have to alter the recipe based on if you don't have enough of one ingredient, you have to change how much of all the other ingredients. Similarly, if you wanted to double your recipe, you have to double all your ingredients, and that would double all your products that you would make. Okay, so we're going to do some calculations with this using proportions. So the first problem says if we have 5 moles of H2S, how many moles of O2 would be needed? So I'm going to say X moles of O2 is what we want to find out, and then 5 moles of H2S is what we are given in the problem. So now we're going to put moles O2 on top and moles H2S on the bottom, being really explicit about which chemical we're talking about, because now we're dealing with 2 different kinds of chemicals. So the only time these 2 things are compared to each other is in your balanced equation, which says if you need 3 moles of O2 and 2 moles of H2S. Okay, now we can take 5 times 3 is 15, divided by 2 is going to give us 7.5 moles of O2 as our final answer. Okay. The next problem down says how many moles of sulfur dioxide could be produced by the complete reaction of 0.25 grams of hydrogen sulfide H2S. So how many moles of sulfur dioxide? Okay, how many moles of SO2 is what we want to find out. Our given information is 0.25 moles of H2S. Okay. We then bring our moles of SO2 across, moles H2S on the bottom, and again we look to our equation. And from our equation, 2 moles of SO2 and 2 moles of H2S. So we take 0.25 times 2, divided by 2, we get 0.25 moles of SO2 as our answer. All right. We're going to look at another equation now that provides a little bit different information. And anytime you have a chemistry problem like this, you want to take a look at the equation. What does it say? So again, we're going to label everything. We're going to say that we need 4 moles of NH3 plus 5 moles of O2, and you will make 4 moles of NO, 6 moles of H2O, in this, and that's different. It's not a chemical formula, but we want to recognize this is a unit of energy. This is kilocalories, and so what it's saying is that when you mix these 2 chemicals together, you make these 2 products, and energy is released. Okay, so if we look at an example and we say how much energy would be released during a complete reaction of 0.25 moles of ammonia, NH3. So we're going to say X, and our units of energy is kilocalories. And what our given information is 0.25 moles of ammonia. Okay. We bring our units across, moles NH3 on the bottom. And we said, okay, we need to get this information from the table because now we're comparing different things. And so when we find our units of kilocalories, that's 108.2. So I'm going to put that next to those units. And for 4 moles NH3, that's going to go on the bottom. So just looking at NH3 and your energy, the equation is saying you need 4 moles of NH3 to make 108.2 kilocalories of energy. Okay. So now we're going to do the math here, cross multiply and divide. So 0.25 times 108.2 and divide by 4, and we get about 6.8. Our units are kilocalories for our answer. Okay, so that's how we're going to use our calculation and do our mole-to-mole calculations using the equation. Thanks for watching.